Hello, today we're going to talk about variables and simple equations. A variable is a placeholder that is usually represented by a number. For example, if I had 6 plus blank equals 9, instead of putting a blank here, I could use a variable to have 6 plus x equals 9. So variables are placeholders that are usually represented by letters. This is where we get those X's, Y's, A's, B's, and all of the other letters in our math. When I'm looking at this equation, 6 plus x equals 9, I can actually solve this one since it's an equation and I only have one variable. So 6 plus what equals 9? 6 plus 3 equals 9. Some equations are very simple, and we can maybe just solve it by looking at it, like you might recognize here, okay, what plus 6 equals 9? It's 6 plus 3. For other equations, we might need to work things out. And when we're solving for a variable in an equation, we need to know what the inverse of each operation we're looking at is so that we can use that. And when we're solving for a variable in an equation, we usually want to get the variable by itself so that we actually know x equals something or y equals something. So when I'm looking for my inverse operations, multiplying and dividing are inverse. And that means they basically do the opposite of each other. So multiplying is I'm taking one number and then I've got so many groups of that number to get a total. So I could say 6 times 3, I have 3 groups of 6 things, and I have 18 things total. Dividing does the opposite. I would take my total, so I have 18, and I'm going to divide that into 6 groups to have 3 things in each group. So I'm basically multiplying and dividing go together, they're the opposite of each other. Then our other inverse operations are adding and subtracting. And this is kind of the same thing. If I had 4 plus 5 equals 9, the inverse of that would be 9 minus 4 equals 5, or 9 minus 5 equals 4. So they go hand in hand, they're just different ways to get to the same thing, or opposite ways to get to the same numbers. So when I'm using this in practice with an actual problem, I could have 3 plus x equals 11. I want to get the x by itself, and to do that, I need to do the inverse of what's on the same side as the x. So I've got a 3 here, and I need to get this 3 moved over to the other side so that I have x by itself. To do that, I'm going to subtract 3 from both sides because this is a positive 3. There's no sign in front of it, and that tells me it's a positive. And another reason I know it's a positive and not like a dividing or a multiplying, something like that, I have a plus sign in between my 3 and my x. Since this is 3 plus x, I know I need to use the positive here. If this was 3 times x, this would be something different. And if I'm going to subtract 3 from one side of my equal sign, I need to keep everything balanced, and I'm going to subtract 3 from my other side of my equal sign. 3 minus 3 cancels out, and I am left with my x by itself, or I could say plus x, but I don't need that x there because when something's positive, you can drop the sign that's in front of it. And then 11 minus 3 leaves us with 8. So my answer here is x equals 8. So let's do another one. I could have negative 5 plus x equals 8. So here I've still got a plus sign in between my number and my variable. So I know this is going to be adding or subtracting. This is a negative 5, so I'm going to add 5 to both sides because the inverse of negative 5 is plus 5. Negative 5 plus 5 cancels out, and I'm left with x by itself. And then 8 plus 5 gets me 13, so this is x equals 13. So the first two we had a plus sign in between our number and our variable, but what if we had a minus sign? What if I had 7 minus x equals 4? So I'm still going to look at my first number to see what I'm doing. If it's a plus or a minus sign, that means I'm going to either add or subtract my number to get it away from my variable. This is a positive 7 because there's no sign in front of it, and the sign of our number is going to depend on what comes in front of it, not what comes behind it. So this is positive 7, and that makes this negative x, and that's going to make a difference in a minute. So since this is positive 7, we've got to do the inverse, which will be subtract 7, and we're going to subtract 7 from both sides. 7 minus 7 cancels out. And we're going to bring down our minus sign because it's a minus sign and minus signs make a difference. So this is going to be minus x or negative x equals 4. And we don't have our final answer just yet because we have a negative sign there. When when all you have left is your variable, and if your variable is a negative, there's two ways you can get rid of this. First, you could divide by -1 on both sides to get rid of your negative sign, because a negative in front of a variable is the same thing as -1 times that variable. So we could divide both sides by -1, or we could just flip the sign of both our variable and our number. So this negative x can turn into x because we're flipping the sign. And if this turns into x, then this needs to turn into -4. And how that would look if I worked it out would be I had negative x equals 4. I'd divide by -1 on both sides. The negative divided by a negative turns into a positive, so this turns into positive x. And then 4 divided by positive divided by a negative turns into a negative, so this turns into -4. I think this is just an easier way to do because we don't have to write out what we're doing. And I've got two more examples. So we did all adding and subtracting, but what if we had some multiplying and dividing? I've got 3x equals 12. And since this is 3x with nothing in between, that's 3 times x. And anytime I'm multiplying my variable, I need to divide that number to get rid of it. And if I do it to one side of my equal, I do it to my other side. So this is going to be divide by 3 on both sides. And then I'm left with my 3's cancel out, and I'm left with 1x equals 4. And then I have one more. This is going to be x over 5 equals 20. Anytime I have a fraction, that's the same thing as division. So x over 5 is the same thing as x divided by 5. When I'm looking at a fraction as division, my top number is my first number in the division problem. My bottom number is my second number in the division problem. So x divided by 5, since this is 5 on the bottom, the opposite of dividing by something is multiplying by that thing. So we're going to multiply both sides by 5. And I'm using parentheses to show that just to kind of help break things up. Divided by 5 times 5 cancels out, and we're left with x equals, and then 20 times 5 is 100. And those are the examples I have for y'all today. I'm planning to do some more on multi-step equations coming up soon. But if y'all have any questions, feel free to reach out.